Welcome back. I'm going to take you through how to set up geodatabases for GIS mapping and remote sensing. So we are going to explore how to use open source geodatabases. And in this, we are going to concentrate on PostgreSQL with PostGIS. So we're going to assume that you are setting up this for the first time. So I'm going to show you how to install your PostgreSQL databases and how to also just install these other extensions that gives it the GIS functionalities that we need. So this is the PostgreSQL installation file. Please feel free to use a later version. For my case, I'm going to work with this. Is PostgreSQL or Postgres. Most people know it as Postgres. Yeah. So 12, this is version 12.4. And then we have this extension bundle here, PostGIS. All right. So this is what now gives Postgres the GIS functionalities it needs to handle geospatial data. Okay. Right. So for demonstration, I'm going just to install it on the local host. But if you're working with field teams, you need to have a cloud resource. So we have very good cloud resource that runs or that comes with Postgres, like DigitalOcean. So if your cloud resource is on DigitalOcean, it will do very well. Also, Amazon Web Service. All right. So yes, it allows you. So these days, we have what we call the containerization technology. So it's what now allows us to run things like databases on the cloud. All right. So yeah, it is a new technology. So let's start. So I'm going to just double click on this. So this installation is for installing a geodatabase on a server. All right. So if you are planning other people or users to be able to access this, so you need to install it on a server environment or on a server machine. All right. Yes. So I'm here on our servers. So just double click. All right. And then the rest, you let it work it out. Tap on next. Now it's going to create an installation folder. All right. So this is where the different various configurations for our databases are going to be stored in. Whenever you want to access, this is where you'll come. So keep in mind, this is mine here is on drive C. All right. So and then next. Now these are the installation components. We have the Postgres server, the PG admin. PG admin allows us to manage our database in Postgres. Stack Builder allows us to work with different tools, database tools. And then we have command line tools. Of course, SQL is command line language, sequential query language. Right, our data goes where? It goes under the same, under data, but you can still opt to have it stored somewhere else. maybe on a different cloud resource for purposes of data security and cyber security management. So for now, we'll just have it here, but feel free to define a different storage location, all right? Yes. Then now, by default, Postgres is GDPR compliant. So first line of security is username and password. So our installation is going to have an admin. So we need to specify the admin password. Yes. The installation port goes to port 5432. I'll have it under the default locale. And then that is our installation summary. Click on next. And there you have it. So the rest is to wait. And you can maybe have a cup of refreshment as it's working out the files. we're at this stage. So there's this checkbox here. Stack Builder may be used to download and install additional tools, drivers, and application to complement your Postgres installation. Yeah, we check it and then we click Finish. And this is the Stack Builder. So with it, we are going to install our Postgres database on port 5432. That is a default installation port for Postgres databases. Although you can still specify a different port, all right? Feel free to explore the different available ports on your server. Now, if it's on the cloud, then it's quite straightforward. It's containerization, right? So you still just go through this under a containerized environment or your container. Yeah, and the rest will be taken care of by the containerization technology. So I'm going to pick this, or you can specify a remote server. Okay, yeah. You can still explore your proxy servers here, but for our case, I'll just leave it at that. Now, just here under database server, you can see we have 13, 14, 15, 16, up to 17. All right, so I'll pick the latest one. This is Postgres 17, 64-bit. Then next. So our installation directory will be database data manager. So I'll define, okay, let me leave that as a default. Then next. So at this point, we'll proceed. We now have the latest database server, that is Postgres version 17. It's already installed, as you can see. Yeah, we at this point, we don't need to install anything else. We advance to the next stage. All right, so the Stack Builder, we said, is an interface that allows us to install other dependencies for our Postgres database, which it has already done by what you've seen. So you can opt to cancel or you can close. We will launch pgadmin. Postgres admin 4 is the interface that we use to manage our databases, our Postgres database. So it's a graphic user interface. Great. So our password, you remember the password you provided during the setup phase? Yeah, this is the time you want to use it. Yeah, so I'll key in mine and then, okay. Never. All right, so we are inside the pgadmin database server or DBMS server. So we have this landing page here. And I want you to see that it's broadcasting from port 127.0.0.1, 54.55.8 on your local browsers. So the first thing, we want to pick a database server that we're going to use. So we currently have two of them, version 12 and version 17. So I'm just going to go into version 17 and still provide my password. That is the admin password. All right, so I've been able to log in into the version 12. So we're going to proceed with that. That is on port 5432. The version 17 is on port 5433. All right, just next to each other. So let's proceed with Postgres version 12. Now, this is the interface. You can see we have some tabs here: file, object. You can disconnect your server, remove server, change password of your server. So a database lives inside a server, okay? A database is housed inside a server, right? So inside a server, you will find more than one database. So you can also host more than one database. Yes. Yeah, so we are going to create our custom geodatabase to help us manage data for our programs and projects. So now to do that, under servers here, you by default, it has already created a geodatabase for you called Postgres. Okay. Now, however, the geo functionalities need to be activated using. Okay, let me take you through how to create a geodatabase. All right. So to do that, you need to run the PostGIS bundle. All right, it's a Postgres extension. So I'll just simply double click on this. And this still has to run from your server environment. Now, at this point, I have the option to choose create a spatial database. So I'll go with this option also. All right, I'll point it here. So it's going to install this geodatabase onto Postgres server version 12. If I wanted it to be on the 7, I'll point it to the version 17. So we move. Port 5432. If I change this port to 5433, it will shift to the version 17 server. Right. So this is the admin username, but feel free to change it. I'll show you how to manage users later. So how do we want to call our PostGIS database? click on close. And we are ready. So now in here, I'm going to refresh. You should be able to see the FAO GDB. All right. So I'll go to the database server and click refresh. Now we have our FAO GDB. So we are currently logged into the Postgres the Postgres database. Sorry, this is not a geodatabase. It's just a normal DBMS. Okay. So I can I'll simply just log into our FAO GDB like that. Now, our GDB is empty. Okay. So we need to import data into this GDB. Right. So how do we do that? So we're going to start. I'll cover that in our next session. See you and thank you. Okay, so I believe, have you had the chance to watch the video I sent about installing PostGIS?
Yes, I actually did install the PostGIS.
Ah, great, great. So,
Yeah.
so PostGIS is a normal RBMS, but whose functionality has been extended through extensions to support GIS functionalities or geospatial functionalities, right? So it's GIS, it's a GIS enabled database, or it's a spatial DBMS. Okay, so it has a function, it has a capacity to handle both normal data, that is quantitative data, and also geographic data at the same time. All right, and it's also one of the most sought after databases when the data involved is spatial in nature. So it's very good, it's very powerful in terms of handling geospatial data as compared to other traditional databases that we have currently in the market. All right. And the other good thing about it is also open source. All right. So you can install it on your own private servers. You can still install it on your cloud infrastructure, like for example, DigitalOcean. Okay. If you're on Microsoft Azure, you should have access to the remote
Okay.
geodata. Yes, Postgres on Oracle. Yes. So it's there. Oracle is also a DBMS, but it's now more powerful. All right.
Yeah, I'm with you.
So
Yeah.
Oracle and PostGIS almost at the same level in terms of capabilities. While Oracle might maybe be expensive, PostGIS is pocket friendly. Okay. So installing PostGIS, that's what you need to understand. Now, at this point, we have our Postgres server installed. All right, and then we have also created a geospatial database within it. It was there on the video, so I believe you've gone through it. Now, I'm going to, this session, I'll be demonstrating how to import data into your PostGIS database. Right? And I will be looking at to import point data, line data, polygon data, and raster data, or your satellite images or remote sensed data. Okay, so what you need to know within QGIS is a very good You see, most databases are not meant to have front-end applications that help us, integrate or interact with the data. That's why it needs third-party applications like pgadmin, like QGIS, like Power BI. Okay, yes. So at the same time, you're going to see how to connect Power BI into Postgres or PostGIS, and be able to still have access to the same data, be able to do your visualizations, without any limitation.
Okay.
Now, within QGIS, QGIS has a very rich source of data connectors or data loaders. Okay, and one of the technology that it has is this ability to connect to databases. So you can see on your browser panel here, one of the options that you have here is PostSQL. Okay, Postgres SQL. Now, how do we access natively? How have we been accessing PostGIS? We access it through what? pgadmin. What's pgadmin? pgadmin is an interface that allows you to manage your Postgres databases.
Yes, right.
Yeah. So if you just go to installation files and PostGIS, I'm running version 17 and 12. So maybe let me just hang here under 12.
I think I need to log on to, because of the Office machine, I cannot install on that. I did it on my private.
Okay. Okay.
I'm just connecting to it.
Okay. So pgadmin, it's here. It's able to run remotely depending with where your geodatabase or your server has been installed. So at this point, this is how you turn it on if you are managing it on a server. But if it's on a cloud, then it will just run continuously without downtime, all right? But because this one here is a physical server, that's why you have to make sure that it's running. Now, most organizations and most projects now are moving away from physical servers to cloud-based servers. Okay, so cloud-based servers, one of the advantages is that we don't have downtime. There's no one particular point in time where you try and access your server, your database server, and find it offline. So as long as you have internet connectivity, you will have access to your database. Okay, so at this point, this is how we manage our database. So this one is connecting to my local host here. And then I have access to the two servers. I'm going to be utilizing the PostSQL version 12. All right, but feel free to run any earlier version, like 13, 14. We are currently on 17. So
Good.
if
I'm
you
trying
are,
to,
yes?
when I installed it,
Mm.
I did not run it, so I'm running it now. It's waiting for it to start.
Oh, okay.
So you go ahead. If it does pop up nicely, I'll let you know.
Okay. Now, within your database server, so Postgres is a database server. So our geodatabase will live inside the Postgres database server, okay? You can have more than one server. You can see currently my server has two databases, okay? So I have the default one that is Postgres. This one is usually created on default when you launch your server. And then I have my own geodatabase here, or PostGIS database. Now, you can have two types of databases within your Postgres. You can have a normal DBMS that doesn't have GIS functionalities.
Okay, so just a quick one.
Yes.
Oh, the current version.
Mm-hmm.
Okay. The version of Postgre is 9.6, but they are saying that the current version is 9.7. That's fine. I can see the servers here too.
Okay.
It says servers, and it's Postgre
Just screen
917.
share. Let me see.
No, it's on the other laptop.
Oh, on the
It's
other
not on the
laptop.
office one.
Okay.
Yes.
Continue.
Let me see. Okay. Hey, hold on a sec. Okay. 2, 3, 5, 6, 5, 0. I need to be writing these things down. Okay, it worked. It worked. It was asking me for the passwords. I just remember
Okay.
it one to say. Okay, so it worked.
All
I've been
right.
able to log in. It's
Okay.
Postgre 17. That's fine.
Great. Now,
Yeah,
you're
so it's
going to
fine.
start.
Everything is fine here.
Okay. Thank you, sir.
Mhm. Mhm.
Now, data analytics, data
Mhm.
science. This is
Mhm.
for most organizations, we build our applications on top of data.
Mhm.
All right. Traditionally, it
Mhm.
has always been first the application and data will come later.
Mhm.
Data analytics and data science is showing us that we can build applications on top of data. All right. So we are utilizing data as a product. I've been talking about data as a product. Data as a product is a new way we utilize project and organizational data. Data-driven processes, data-driven alerts, notifications, workflows, data-driven workflows. Okay. Now, anyway, we'll get back to that. I just want to show you how to navigate and how to access your data if you're having it on postages. Now, for most organizations, you'll find them, if they are handling geospatial data, then it will definitely be a postages database.
Mhm.
Okay, you will never go wrong with the PostGIS database. You might choose to work with different databases. You can extend their functionalities by installing Spatial extensions, like for MS SQL, Microsoft servers. We have them extensions for geospatial data, different extensions that are compatible with the platforms. Oracle also has one, MySQL, and the list is endless. Just know now. It doesn't matter which platform you are. Just understand how spatial data is handled. Understand the principles that we talked about.
Mhm.
If you're talking about coordinate systems, very important. If you're
Mhm.
talking type of data, lines, vectors, rasters, very important. Just know how to manage them.
Mhm.
Now, inside here, on our geodatabase, you can have different data sets. So you have been used to files like shapefile, like
Mhm.
GeoJSON. So in here, every file, every data set that you upload into your geodatabase
Mhm.
is going to be an individual table. All right. What do I mean? So inside your geodatabase, the next thing that you want to look at are the tables under schemas. Schema is just tables, an arrangement of tables. So we have public. If you see Tiger data and topology, this just tells you that your geodatabase is spatially enabled. So under the public schema, these are GIS, and GIS. These are GIS functionalities. Under public schemas, you have tables. Okay, this is where your data resides. Okay, now you can see I have a table here, FAO field farm survey. All right, I have another table here, NDVI anomaly. I have RF stations. I have Chilo agrofarm GDB parcel area size, farmland land parcel. I have Kakuma tanks, Kijiji camp buildings. No, all these were individual datasets that were uploaded into our geodatabase, into the FAO geodatabase. And it has resulted into an individual table. You remember what we said about GIS? maps
Mhm.
plus database.
Mhm.
GIS equals to maps
Mhm.
plus database. So
Mhm.
Postgres is a DBMS, so it understands data in terms of tables, right? That is
Mhm.
why you are not first seeing the map.
Mhm.
You are seeing the table first. So the map
Mhm.
is somewhere within the table,
Mhm.
okay? So this is version 12. On version 13, you should be able to see the maps loading. But I'll try and see what we have. Like this is Kakuma tank, right? Okay, let me load ours. It was this, yeah. So to view this, I'm going to maybe steer a little bit away from SQL because we have an entire course on databases, Postgres database,
Mhm.
and
Mhm.
whereby we build apps, GIS-based apps on top of your
Mhm.
database, right?
Mhm.
And you can use this within your office with your field teams just to be able to take full advantage of your data sets and the different workflows that are supported by your data. So for now, we just do data management. So visually, you can just right click if you're within the PG admin. I always recommend that you work with PG admin, although you can still work with the command line.
Mhm.
But you don't need to stress yourself when there's an easier way. So work with PG admin. It's a graphical user DBMS for
Mhm.
Postgres,
Mhm.
all right?
Mhm.
So
Mhm.
you can view your data, all right? So every step here that we are doing can be written as a script, as an SQL
Okay.
script. Yeah.
Okay.
So databases, they use a language called sequential query language, SQL. This
Mhm.
is how they communicate. This is how they store data. This is
Mhm.
we call it CRUD operations: create, read, update, delete.
Mhm.
CRUD, CRUD, CRUD.
Mhm.
Create. You can create records. You can read the records. You can update the records, and you can delete
Yeah.
the records. Those are
Mhm.
standard database functionalities.
Mhm.
Okay. So
Mhm.
we can view. View is reading. Yeah. So I'll say maybe all records for now, or maybe the first 100 records, or just let me say all rows. So you can see that this was the data from ODK, from Kobo. I'll show you how I got it in here. So you can see we have our table in here, and you can see there what we had on our ODK form,
Mhm.
our household field survey, our field form. There, you can see respondent K, M, and V. This is what we did during the data collection exercise.
Mhm.
Yes. Now it's sitting in here within our PostGIS database. And then we have a column here called geometry. And this column called geometry has an icon here that looks like a preview icon. All right. So if I click on it, I get to see the geometry viewer window. All right. But for some reason, it's not showing us there. It's because it's an earlier version. If you're working with 13 and above, you should be able to see an open layers layer for your data. So this is the SQL that was used to load our data. This one here, let me just close this folder. This here, select all, that is the meaning of star. Select star from
Mhm.
public.
Mhm.
And from which table? Public shows the schema, and this is the
Mhm.
table name, right?
Mhm.
So I'm not going to go into that, but it's something that you can also explore if you want to really understand this. If you'll be working remotely, then you need to also understand command line. We have PGSQL command line, right? I'll not go into that because I want us to first understand this concept. Now, you can also access these other files by using the same process. And you can see the SQL syntax is the same. What is just changing is the address to our tables. Oh, you can see, yes, this is what I meant. You can see this one is showing. This one for Kakuma tanks. These are refugees. This is the largest refugee in Africa, refugee camp. Yes, it's in Kenya.
Yeah, really?
Yeah.
Right.
It hosts refugees from within the region, Somali, Ethiopia,
Oh,
Uganda,
I see.
Burundi, Rwanda, and the Congo.
Hmm.
So it's really huge. It's really, really, really huge. And most of the humanitarian implementing agencies, they work here. So yeah, it's an entire
I
farm
see.
for humanitarian work.
Hmm.
Yes,
Hmm.
you can see.
It's called Kakuma.
Kakuma refugee camp.
Okay.
Yes. You can see how even the other data, custom data has been loaded. All these are refugees. All these buildings you are seeing here.
Yeah, so for example, this is how the Budumbran camp should have been. You see, this looks like it's well planned.
Yes, yes, you are right. It's well planned.
Okay, it's
Yes.
planned, and you can see driveways through
Mm-hmm.
and what have you. But the one that was done here was not well planned.
The one you mentioned to the right,
Mm-mm,
to the left of
mm-mm.
Accra.
Yeah, it's not. It was not well planned.
Yes. So that is a typical geodatabase, PostGIS database. This is how it should function. You can see now, even within the PG admin, I'm able to see my data. And then even on these points, when I click, I'm able to see a pop-up that displays the data value at that particular point. So you'd like you
Of
can
course,
see.
then this will be GeoJSON then.
Uh,
Are we utilizing
now within a
GeoJSON here?
yes, it uses the GeoJSON functionality, but now currently this is inside PostGIS.
Oh, okay.
Yes,
Okay.
but you can
Okay.
export it. You can export it to any spatial format that you will want to have. I'll show you within QGIS. All right. Yes. So PostGIS
Okay.
also it works with GDAL. You remember GDAL? Or
Yeah, you said a collection of tools and standards.
yes. It's universal, so that's why the data sets are having an easy time in terms of compatibility and in the way they are displaying. Yes. Now, so how did we get this data inside our geodatabase? Okay. So if you're doing it for the first time, I recommend, even if you are professional, I recommend just work with QGIS. QGIS has a robust resource for all this. Okay. Now, on its own, PostGIS comes with its own GIS upload interface. Okay, it's called the shapefile to PostGIS. Sorry, where? This one here, PostGIS. PostGIS shapefile import export manager. Okay, so if your file, so this connector here allows you to import data into PostGIS database. Yeah, so you can bring in your DBMF here. Like for example, let me load something that you'll appreciate. I want us to load the map files for Ghana. All right, map files. Let me see what I have. Oh, this is Accra region. Let me just maybe load the map files for Ghana. Let me see it's sitting. Also have rainfall station. Oh, I have rainfall station. I have rainfall stations here. So I'm going to load these rainfall stations. And we see how we're using the shapefile loader, shapefile import and export manager. So the first thing that you need to know is where your shapefile is currently stored. Mine should be where? Properties. Oh, yes. It's here. Let's see. It's currently in GeoJSON. Okay. So this one is currently in GeoJSON. Let's see. So if it's currently in GeoJSON, you can see it says it's a shapefile import export manager. So you can only load a spatial data that is in shapefile file format. So if it's in GeoJSON, what you do, you convert to shapefile first. So I'll do that maybe right away. I'll say export, save it as, I'll have it as a S3 shapefile, and then this post GIS. I'll say RF stations. Or just weather stations. So maintain S3 shapefile and then save. I want you to notice this. Okay, this is our local coordinate system. It is what? A local coordinate system. I'm going to do something to it. Just maybe take it back here. WGS84. Right, and then you can say okay. Now, if we access PostGIS, we should be able to see it. So this is where my shapefile is. So it's ready, I've prepared it, it's ready to be uploaded or imported into PostGIS. So the next step is to switch back to your PostGIS here. So we have view connection details. So the first thing that you need to do, make sure that your server is online, meaning that it's running. Okay, you can ping it. We'll talk later about pinging. But just say view connection details. At this point, you need to connect. So you need to know the username. You need to have an existing username. I'm going to use our admin. So I'll say just Postgres, but you can use other usernames. I'll show you how to create users. Password. And then the server host, okay? The server host. So this is where you now put your IP address if it is remote, okay? You enter it here. The port based on that server, sometimes it might change from 5432 to something else, but by default that it is, you can find it 54, 32, 33, 35. The database, okay? Always know the database where you want your data to be imported to. So I'm going to put it under FAO-GDB, okay? FAO-GDB is this database that we are having here. What is it? A little up. FAO-GDB, this one here. So we're going to import a table in here. The name of the table is rainfall stations. So I'll come here. I'll make sure that my connection has been sorted. Oh, yes, it's here. So, okay. If it's successful, you should be able to see connection successful. If it's not successful, then it means either you have not provided the correct username or the correct password, or your database name is wrong. Okay, so mine is here. The next thing that we do is to add the files that we want to import. So I'll say add file, and then okay, let's see. It's here. It's under PostGIS. So this you can see the formats that are supported: shapefile and DBF. All right. So just select open. Now, once it's here, you don't need to do much. Just come and make sure the SRID matches what you had, 40, 43, 26. All right, that's the part a lot of people usually overlook this. Okay, and once you provide this, so this is the WGS84. It is a coordinate system associated with this data set, the default one. So then click on import, just like that. And the next time you come under your tables, you can just select refresh. And this time you should be able to see you have your rainfall stations. You can see it is here. So zoom to, you can say view all rows there. All right. So our geometry, I can click this to view our geometry. And there it is. You can see it's displaying where it was taken. This is Ethiopia. This is live data. All right. This is real data. These are actual rainfall stations in Ethiopia. All right. This is a project we did for climate monitoring for agro-pastoralist communities within the area, the Borana National Park. Yeah, so any questions up to this bit?
Again, like I said, with these, from the way I learn, I need to make sure I have it done. Okay.
Yes.
Then
Yes.
when I do it, that's when my questions come.
Okay.
Because I always want to appreciate the thing. Yeah. I would not be fair if I'm asking questions now, because no, I need to do it.
It's okay. Yes.
Yeah.
Okay. Now, the other thing, the next step is if you're working with the QGIS. So how do we do this? Now, PostGIS shapefile import export is limited to only vector data. So you can import point, line, and polygon data using this shapefile. So requirement is that your file should be in shapefile format. Now, if you do not have the time to convert them into the, what do? You work with QGIS. QGIS is one of the most powerful geospatial data viewers. Okay, it's able to read a lot of, you think of any spatial file format that you can think about, QGIS will be able to read and display it, including including things like how do you call it, AutoCAD files. Yes, it's able to read AutoCAD files. So I'll circle back to our QGIS here, and I'm going to load Ghana regions. Let me see. Ghana regions, right? I'm going to load this file here. So you can see that is currently a shapefile, but it can still be a GeoJSON. In QGIS, the file does not matter. So what you need to do is to first create a connection to your database by going to browser, and under PostSQL, you can click here and say new connection. Right? So when you click new connection, I can say FAO host, I'll say it's local host. The port here is 5432. If it's not, you can update. It can be 33 and all that. The database is FAO GDB. The other, I'm going to leave them like that. And then I'm going to do something here under basic, under basic. I'll provide a username that is Postgres, and then a password. Okay, and then test the connection. And you can see the connection is successful. So it means I'm connected. So you can proceed by just closing this. And then you should be able to see FAO PostGIS has been added as a database connection to QGIS. Right. So if we expand this, you can see the different schemas that we have. Under public is where we want to have our database coming to public schemas. So we have so this is the first step, establishing the connection to your PostGIS database. And then the next thing is to work with the database interface or the DB interface for QGIS. You find it under the menu here, the menu bar, under database. All right, select DB manager. So within the DB manager, you'll find the different providers. Go under PostGIS. All right, expand it. You should be able to see FAO PostGIS listed there. Okay, and in this part, we want our data to come in here. So what do? We select the import. So select import. And then you can see I had selected Ghana regions, but you can always come and pick what you need from this list. Okay. I'll say you also have the option to only import selected features. The schema is public. The table is going to be Ghana regions. The source ID, you can see it has detected and it has been able to pick it up. So we don't need to change anything here. Maybe the only thing I can do is to just say okay. And you can see import was successful. Let's see whether it was able to go inside our PostGIS. So if I extend this, if I refresh, and then I go into public, I should be able to see Ghana regions here, right? Yes, so you can see Ghana regions, you can see the table is here. I can look at the table, it is here. Okay, I can also look at the preview there. All right, so if I circle back to my PG admin, I should be able to see that data set. Cancel. I'll just maybe refresh. And now we have Ghana regions. Just view data on rows. All right, and then I can view the drawings here. There you have Ghana.
Mm.
That's how you import your data. Now, this is just a preview. You can't do much in here. So if my data set was sitting inside PostGIS and I want to visualize it in QGIS, I want to load it from PostGIS to QGIS for analysis and map making. How do I go about it? Similar steps, okay? You make sure you have a connection, okay? You make sure you have a connection. So for this, I'm going maybe to start with the DB manager. So within the DB manager, just navigate to PostGIS. All right, navigate to PostGIS, go to where your table is. Let's say if it's Ghana regions, you can load it as Ghana regions by maybe let me load something different like this one here. You can load it and say add to canvas. All right, add to canvas. So when you do add to canvas, can see there. Okay, that's your data. That's your data here from PostGIS. Any question to this bit?
Practice. I must practice it. So let's see.
Now, if you are not working with DB Manager, you can work natively with the QGIS native Postgres connector. By coming to browser, and making sure you have an active connection like this, and then just expanding and going to where your area of interest is. Okay, like this. So you simply just right click and say add layer to project, or you can just drag and drop. Right, like that. Yes.
Okay.
When you come to layers, you should be able to see that it has been added, these two. And then from here, you can do the styling. Now, the other thing about QGIS is that it enables you to store your map styling into your database so that the next time you load it, it doesn't default to these random colors. Rather, it should be able to maintain the original styling from the map designer. Okay, so up to this bit, any questions?
No. No.
Very good.
It's understood. The whole concept is it's not foreign. It's not foreign. It's like we did bits and pieces in the study, but now it's coming together.
Mm.
But for it to be appreciated more, I need to put my hands on it.
Yes, you are right.
Mm. I need to put my hands on it, and there's a lot I have to do. We'll take it one by one. Don't worry.
I'll be here anytime you need assistance. Now,
But what I'm planning to do first is just as we are studying, I'm picking up. So what I'm going to do is this weekend when we travel,
mhm,
I'm going to pick up. We have a little place at the countryside. I'll pick
okay.
up. I'll see if I can use my phone
Mm,
to pick up the points, and then I'll try and load it into QGIS
mhm.
and then locate it on the satellite. We'll take it one by one, and I'll be sharing it with you as I move along.
Okay, that's fine by me. Now, if you're doing change detection, all right, you store your map output. So if this is the anomaly, remember this anomaly, you can store this, you can upload this directly also into
QGIS.
into PostGIS, right? This one here. Okay, you can upload it into PostGIS. So let's see how it looks like. Right? There you are. This is our anomaly, Greater Accra NDVI anomaly. Yes. Yeah. So this is still vector. So what of if I'm having a raster data set? How do I go about it? Right? So for a raster data set, for a raster data set, you need a specific connector, a specific plugin for QGIS. Right? So for this, you go to the plugins menu here, manage and install plugins. And the plugin we are looking for is PostGIS raster importer. I think it's PostGIS raster importer. Yes, PostGIS raster import, this one here. Okay. We have others like PostGIS sampling tool, PostGIS toolbox. We don't need to worry about those. Just go and pick PostGIS raster import. All right. We will still have PostGIS geoprocessing tools and all that, but yeah, you can explore. Feel free to explore them. So select this. To install this, once you install this, it will give QGIS the functionality to import raster into PostGIS. That is how plugins work. They introduce a functionality that was not there previously. Right, so we are able to extend the functionalities of QGIS through custom plugins. Right, so how robust your QGIS is dictated by what you do, by what you think it can do, right? So, and we do that through plugins. All right, so just install. Mine I'd already installed, so you can say reinstall and install. I just click install. Once it's done, you can close. And then under raster, under database, you're going to see a new addition here that says PostGIS raster import. Okay. PostGIS raster import. So what I'm going to do, I'm going to upload a data set here, Greater Accra 2020. Okay, I'm going to upload even maybe these two. So these are the NDVS values that we got from FAO data portal. So just for now, we can turn it on just to see where it is. One is for 2015, another one is for 2020. Now, on your database, launch the PostGIS raster import. You'll be able to see a window like this. So start, the only limitation with this right now, it's running one at a time. So raster layer, we'll pick it. I'll say I can start with the one for 2015. DB connection, I'll say I'll use the one for FAO PostGIS and provide the username and password. Then okay. So if it's able to come back, it means that the connection was successful. So you can see our table is going to be stored under the public schema, and the new table name is going to be Greater Accra WA1547. Okay. You can, after you upload it, you can load it into the canvas. But for now, I'll just load it by saying upload. There. And you can see upload finished. Right? Now, if you maybe come to the database, under browser, I should be able to see Greater Accra WA47. I'll simply refresh and you can see it. Let me scroll it down. You can see here, Greater Accra, West Africa 1547. And you can see it's a raster file. Just like that. And to load it, I can say maybe new, I can load it here. All right, yes. There. So you can see the quality doesn't change. It's still overlaying where I expect it to overlay. Yeah. That's how you upload raster files. Any questions up to this bit?
Interesting.
No, we proceed.
Question.
Yeah. So I think we are good with databases in terms of management for spatial data. Now, don't worry yourself about writing SQLs for post GIS. right?
Mm.
You can have your database at project level, at organization level. You can have your post GIS. You don't need a third-party application. You can still use QGIS to do everything that you want.
Mm.
All right.
But then
still,
you can only do that when you understand the entire structure of the thing,
yes,
you know.
yes.
And that's really why I am coming to you guys. Like the other ones were doing it, but once you appreciate like what we're doing to really understand the thing, then you can apply it in. That's why I like the hands-on and to really practice it. Mm.
Yes. What's your suggestion right now?
Mm. Oh no, let's go. I just have to buy the time
Okay.
and do it. Now that I have the QGIS
Mm-hmm.
um and both the SQL also running
Mm-hmm.
on the my personal PC, I need to virtually practice everything there, and then we'll take it from there. You don't worry.
Yes, you are right. Now,
I need to really
proceeding
do
to
it.
the next one.
Mhm.
The way we've worked with the NDVI
Mhm.
um, from Modis, the Modis file. Now, let me mention one important thing about raster datasets or remotely sensed images. Mostly of the remote sensed images have a specific way in which they should be handled based on the sensor and the platform that was used to acquire that data.
Mhm.
That's why you'll hear of people saying Landsat imageries. Someone will say Sentinel imageries. So they will start maybe with the platform, that's the Landsat imagery. So these are satellite imageries or remote sensed imageries that have been acquired on the using the Landsat platform, right? So each of these platforms have specific sensors, mostly specialized for a particular functionality or a particular application. It can be forest monitoring, fire monitoring. Yeah. So you need to understand the producers or the providers of these satellite imageries. How have they documented on how this data should be used and pre-processed, especially under pre-processing. Okay, so how you work with the Landsat data is slightly different with how you work with specialized satellite imageries like eMODIS and EVIRS. That is the NDVI from that. But still, Landsat with one or two spatial algorithms here and there, you should be able to generate your NDVI dataset from raster, from Landsat rasters. Okay, so there's a shift from they are trying to move away where the end user has to really go through a lot of pre-processing. So they are providing us with already processed products. So the analyst already has data that has already been processed. What they need to do is just analyze and report on the findings, like what we are having with eMODIS and EVIRS. For Landsat, it will have been a different story. You have to run some pre-processing techniques.
Mhm.
Yes. So just always be on the lookout. Every time you download your data, your raster data, especially if it's Landsat, they will have some, I'll give you some materials just to help you, guide you through. But you can see, based on what we have been using so far, the data is pretty good and it's ready for use. You just need to know how to analyze it.
Mhm.
Now, when you are integrating GIS with other aspects or with other themes like household data,
Mhm.
you'll need to understand sampling techniques. Okay, if it's rainfall data and all that, this will introduce us to interpolation. Interpolation is where you use data from the available few samples to determine or to model or to create values for the other missing samples. Okay, so for example, I'll circle back maybe to the previous one. Now, this is in relation to PCA, Principal Component Analysis. Now, GIS has already showed us that our remote sense images are saying that there's a decline in vegetation cover over the years from 2012 to 2025, all right? Spatial techniques have already proven that. But are we having the empirical analysis? If we are having a p-value to reject or fail to reject, so what happens now? If you're having a p-value, it means you have an hypothesis. So you can either keep the hypothesis or you can reject the hypothesis. Now, this now requires you to understand some bit of geostatistics. Okay, so where does this raster comes in terms of geostatistics? Okay, and to do with point sampling, you will find you have a data set. We talked about resolution. Okay, we said you have finer resolution satellite imageries or remote sensed imageries, and then we have coarse. And this has to do with the pixel size. So in 1 pixel, what area on the ground is represented by 1 pixel? Okay, so you'll find that if you're working with historical data, earlier satellite imageries had a coarse resolution. Okay, as compared to the current satellite imageries. The current ones, oh, they are perfect, they're wonderful, I'm telling you. They are very high resolution, up to a centimeter. It was up to a centimeter. Okay, up to a meter. Once you get to a meter, it means it's very high quality. So when you have data sets that are in different spatial resolution, like let's say if I was doing a satellite data maybe from 2000, I have here 2012. Let me assume that I have another data set from 20. Okay, we can still use this one. You'll find that the one from 2012 is of a coarser spatial resolution as compared to 2025. So how do you harmonize your analysis? Because spatial resolution is a big deal in spatial analysis. All right, we work with point sampling. If you are trying maybe to compare between NDVI, rainfall, precipitation, evapotranspiration, soil, you'll find that these data sets will be in different spatial resolutions. So working with those values the way they are might not work for you. So what we do, like for my case, I wanted to understand soil, I wanted to understand precipitation, I wanted to understand temperature, I wanted to understand humidity, I also wanted to understand NDVI. So these were 5 indicators that I was working with. So and I then noticed that some of these data sets, depending with the indicator, they had different varying spatial resolution. So to harmonize and make sure that my analysis and output was of high quality, I needed to create samples, sample points. Okay, so I was coupling my data with household surveys. Okay, so the first thing that I did was to create samples. How do I create samples? Samples is a great way. And why do we need sample points within our region of interest? They will help us carry out principal component analysis. So in principal component analysis, we are saying from this particular point of observation, across the various indicators, is there any relation? And if there is any relation, is it a direct relation or is it an indirect relation? Okay, so I'm going to do point sampling whereby it's going to extract raster values for NDVI. So I'm going to determine a number of sample points on this region, and then I'm going to use it as my benchmark.
Mhm.
Okay, because just picking the entire region like this and doing your analysis as a bulk is not feasible. Certain aspects might be overlooked. So we're going to narrow it down through the use of PCA, the principal component analysis technique. And this requires us to generate sample points. Now, this is Greater Accra. It's huge. It has a huge spatial coverage. So we need GIS tools under vector. All right. So under research tools, we have something that says random points inside a polygon or random points in polygons. Okay. Now, if you're talking about sample size for Greater Accra, let me maybe just click here and explain what this does. So this one is going to generate a series of points inside our Accra polygon. So I'm going to say I'm working with Ghana, Greater Accra. Yes, Greater Accra region. I need number of points. I need like maybe how many do I take? I can have 3,000 points, sample points for Greater Accra. Minimum distance for now, let me just leave it the way it is. And then my points are going to be stored somewhere. So you can store it into a geo package, a file, or into your PostGIS here. All right. So I can say, maybe let me store it directly inside PostGIS. And then I'll say Greater Accra 3,000 sample points. Okay. And the table. And then we just run. Now, if it's giving you problems, then don't worry about it. You don't need to, you can always pick a different destination. You can say, instead of working with the database, let's work with a normal file for now and run our analysis. So under point sampling, let me have it under IDW interpolation. So I'll say and then I'll say save. Then we'll run. Let me call it 3,000 sample points, then run. Good. Okay. Oh, okay, it's loaded, This. So I'm going to use this as my sample points, okay? So that is 3,000 sample points. Now I can use these sample points to pick the NDVI values of each specific area of where this sample point is on the map. Okay, so how do I do that? To achieve that, I'll simply come to raster. So here we're going to use points to extract raster values. Okay, and for this you work with extraction. Let me switch to processing toolbox. Under toolbox, just say raster sampling, and you have sample raster values. Okay. Under raster analysis, so sample raster values. Double click on it to load. Now, before we go there, I want you to notice on your points, on your sample points. Let me talk about the sample points first. Let me open the table, attribute table. And you can see it's here. It has inherited the administrative boundary information, but it has nothing about NDVI values. Okay, it has nothing about NDVI values. So we are going to use this data set to extract. So we have the random point here running from 0 to 299, 3,000, yeah. So we are going to end up with 3,000 sample points with values, with NDVI anomaly values that will tell us where the change has occurred. And then we're going to take it into a platform like Stata, right? Or Mendeley. Mendeley is this is statistics and research, but you'll just understand them. To do more, refined analysis, especially inferential, if you are trying to prove things to do with hypothesis. If you have a hypothesis, if you're working with one, then you want it to be done this way. So sample raster values, our input layer is okay. It's this one that we have picked. Our raster is the one that we want. So I'm going to pick the greater anomaly. Not reclassified, the normal one, just the greater anomaly from 2025 to 2012. We pick it like that. And then I'll call it NDVI. Save to file. I'll say Greater Accra. Okay. So Close. We access the data table. Then we look at what we have created. And here we are. Okay. So you can see the different values in terms of change. So from here, you can look whether this change is it being experienced in many of these points or not. Okay. Now, if for some reason you find that maybe these points are too much, all right, like I done one for 5,000. Let me see where it is. 5,000 points. Okay, let me use this. It's 3,000. Let's say now I need maybe to only work maybe with, because of budget and all that. You need a smaller sample, all right? You might want a smaller sample, like maybe you want to work maybe with 1,000 or maybe 500, right? Let's maybe pick 1,000, right? So for that, you need to know how to work with the research tools, GIS for research tools. Now I'm going to tell GIS to randomly pick 1,000 points from these pre-existing points, these 3,000 pre-existing points. Okay, so how will we do it? I'll go to vector under research tools, and then I'll say select random selection. Just pick this, and then we'll tell it, yes, this is a one, this is a point data set, the one that we have just created, the one for 3,000, anomaly, NDVI, and then method, you can either pick the number of selected features or percentage of selected features. I'll say number, and then I'll say I need 1,000 points from this 3,000. So that is it. And then we run. So what this is going to do is to select, okay? So we don't need an output file because it's selection. So we run. And that is your three, the ones that are in yellow. That is your 3,000, that is your 1,000 distribution of those points. So I can then come and they are still here. I'll export only the selected samples. So export selected features as. I'll come under that was what interpolation. I'll say this, and then I'll say 1,000. Then I'll save, and then okay. Now remember this part should always be checked. Save only selected features.
The features, okay.
Yes, and then I can say okay. There I am. So I'm going to use these points. Let me now bring it down. So these are my 1,000 sample points. I'm going to take my vegetation data set. I'm going to take my rainfall data set. I'll take my temperature data set. I'll take my soil data set. And then I'll use these sample points. I'm going to compare that data. If we are experiencing change in NDVI, are we also experiencing change in temperature? Are we experiencing change in humidity? Are we experiencing change in precipitation or rainfall? All right, that's how principal component analysis works. So it will look at the rate of change and tell us whether there is a relationship or not.
component
Okay. Yes.
analysis. Okay.
Yes. So you extract your values. So if I'm doing now principal component analysis, it works well when you're also working with time series data.